welcome to the Prince George's County Public Schools MSA Prep. My name is Coach Sun here with my fabulous partner,
Coach Davis.
Thank you, and we are here to help you get ready for MSA. We know that you are ready. You are not only you're past basic. You are proficient and advanced, and you are going to show everyone out there how ready you are for MSA. We are here to get you just a little bit more ready and show you some tips. And to do that, we are going to use some public release tasks from www.mdk12.org. Here's a sample of what the public release task looks like. This is a public release task from grade 4, and we're going to use some different release tasks from that website. So we suggest you go on there and look. They have release tasks from grades 3 through 8. So to get started, I'm going to do an activity from a 3rd grade task. And this task, here you will see the grade in the top corner, and they will always let you know if there's a calculator allowed during that session. So here you will see a no calculator symbol. So to complete this activity, we will not be using a calculator. So let's take a look, and we're going to be working through some different strategies. And Coach Davis, please feel free to chime in. She's got some excellent strategies. She's a pro. So let's go ahead and take a look at this activity. It says, look at this number sentence. What number should go in the box to make this number sentence correct? Very tricky. And here's what I like here is that we see this equal sign, and I want to talk to you for a moment about this equal sign. This equal sign is exactly like a balance scale. And anytime you think equal, you think both sides want to be balanced. And that's what can really help us out. Anytime you see that equal sign, think of a balance scale, and you want both sides to be balanced. So you know that the two sides need to have the same value. So what we can do is we can actually go ahead and we can work things out right on the test, and that's one strategy that I suggest you do. Go ahead and work things out right on the test. You're allowed to do that. You'll have scratch paper, but you can also work things out right in the test booklet, and I suggest you do that. So to know that both sides need to be equal or balanced, I first need to look at the side that already has both numbers, all numbers filled in there. And we want to go ahead and we want to add those together. So 13 plus 7. So we can go ahead and add those together. And I know that 3 plus 7 equals 10. And 1 plus 1 equals 2. So I know that the value of these two numbers together equals 20. Knowing that there's this equal sign, I know that this side together as well is going to need to equal 20. And we've got this box here that we need to fill in. So we know that 6 plus 4 plus some other number is going to equal 20. So first I want to add 6 plus 4. And I know that 6 plus 4 equals 10. So the question becomes 10 plus what number equals 20? So that's what we're really trying to figure out here. 10 plus what number equals 20? Because we want these both sides to be balanced. We want them both to equal 20. If you know your basic facts, you know that 10 plus 10 equals 20. And that can help you out there. If you're not sure, then you're going to want to find the difference between those two numbers. So then what you could do is actually find 20 minus 10 equals 10. But if you do know your basic facts, you'll know that 10 plus 10 equals 20. But work things out here, solve things out, and use this space very carefully. But remember that equal sign means the two sides have the same value. So things can switch sides, it doesn't matter, but the two sides need to be balanced. Extremely important, okay? Here you will also see a lot of different options, and you can feel free to cross out different options and eliminate answers as you go. You're often going to see some choices that are there to trick you. Let's go ahead and fill in our answer choice. I'm so excited about filling things in here. Forgot to make sure to do that. So A, 10 is our correct answer, okay? Notice that 7 plus 3, which equals 20, or both sides themselves separately have a value 20. That answer choice is there too, so be careful not to get tricked and read that question very carefully. Anything else you want to add, Coach Davis?
You have done an excellent job,
Coach thank you so much. And Coach Davis has some excellent activities to help you out as well. So here we go.
And for this particular activity, it is a 4th grade activity, and again, the calculator is not allowed. And this is a copy as it is seen on your MDK-12 website, but in order for us to see more clearly as we are doing the problem, we have an enlarged version for you to take a look at. And my number 1 strategy is always to read the question very, very carefully, and sometimes you may need to reread the question. So whatever you need to do to make sure you're understanding what's happening. So let's read this question carefully, and we may have to read it a second time, but let's begin. Molly cuts this piece of tape. Here it is right here. And I see this right here, which is an example of a ruler, and I see it says inches. So let's look at the question. And the good thing about MSA, they're going to put the question in a box for you. So how long in inches is the piece of tape Molly cut? Okay, so I want to know how long in inches is the piece of tape. And if I take a look at my answer choices, I see that it's 4 inches, 4.5 inches, 4 3/4 inches, and there's actually a 4th answer choice that is D, that is 5 inches. So let me go ahead and put that on.
You can put that on there, but you know what, if you don't mind, I think we can actually cross that one out.
So in part of
what?
Yeah, Coach, why do you think we can cross that out?
Do you know why I think we cross that one out? Because, well, it does say the closest, how long in inches, but do you know what? It hasn't even gotten to 5 yet. We know it's not 5 inches yet.
Okay, so that is something we can keep in mind as we're solving this particular problem.
I think we can cross that one out.
So a ruler is just an excellent example of fractions. So let's see if we can identify the values of these parts on the ruler. So here we have 1 inch, and if I count, I have 1, 2, 3, 4 parts there that it takes to equal my inch. So I know that each part right here is 1/4. So this is 1/4. And notice that this part is a little bit longer. It is halfway between. So we have a choice here of either writing this as 2/4 or 1/2. I'm going to use 1/2. And then, so this was 2/4, so this would be 3/4. So we have an option of either labeling this as 1/2 or labeling it as 2/4. So since all of these are in fourths, and let me check, this one comes right here to 1, 2, 3, the 3rd mark. So this would be 1/4. This could be 2/4, which is the same as 1/2. And so this would be 3/4. So I see that it's divided into equal parts. So let me look. It is between 4 and 5, not yet to 5. So it would be 4 and 3/4. Let me see if they have that as an answer choice. I see that it's not 4 inches. I can cross that out. 4.5. I know that 2/4 is the same as 1/2. I can cross that out. And so my correct answer choice is 4 and 3/4.
I have a question for you, Coach Davis.
Certainly.
Two different questions. One, what would we do if the tape didn't start until the 1? Would there be a way to figure out how long the piece of tape is if it didn't start at 0? What would we do then?
We would still count to see how many inches it is. So if the tape started right here instead of, so this is, we've answered the question as it is given.
As it is it. Yes,
as it is given here.
As is.
And so if we're adding on
additional question.
So if the tape actually was not lined up with the end of the ruler, we would still count to see how many parts it is. So instead of saying 1 right here and 2 right here, this actually would be just 1 inch, and this part right here would be 2 inches. This part right here would be 3 inches. And still we're putting this in, these are still our segments. And again, I can count to see 1, 2, 3, 4 to get to the next. So these are still fourths. So this is 1/4, 2/4, which is the exact same thing as 1/2. And this is 3/4. So in that case, if this part of the ribbon was totally missing and I was just measuring this segment, it would be 3 3/4, which is a different question.
It is a different question. I just heard about that. I've heard about some broken ruler questions, and I was just wondering about that. So excellent job, thank you. Something I also love what you did here, Coach Davis, is I love how she was not only eliminating answer choices, but if you notice, she was doing that to the right of the questions, because we want to be very careful not to do that over the answer choices, because computers scan these tests,
Yes.
and we want to make sure that they don't accidentally pick up something. If we were marking something as eliminating it, but by mistake we went over the answer choice, we want to make sure that we don't do that so that the computer doesn't pick it up by mistake. So I love how she was eliminating it to the right side of the answer choice. Excellent job, Coach
And that
Davis.
is definitely a strategy that you can use with your test.
Excellent, fabulous.
Okay, and Coach, do you have a question you want to show? Some additional strategies?
I love that. I think you did a fabulous job. Another thing, just so you know, if you have a ruler as well, sometimes they're broken up into 8 equal parts or 16 equal parts. So the same thing you would divide if you were looking at a number line and you break them up into 4ths or 8ths or 16ths. The same thing with a ruler, because a ruler basically is a number line. So you would use the same strategies. Okay. What I'm going to do with you is actually we're going to jump to a 6th grade task for a moment, okay? And I love this activity. It's a really, I think it's a fun activity. Let's take a look at this question. It is a 6th grade question. And if you'll notice, we are allowed to use a calculator. So we're going to go ahead and we're going to do that. We're going to use the calculator. And we're going to go ahead and I'm going to show you the enlarged question right here. The question says, look at this rectangular sheet of wrapping paper. So I see in this rectangle that we have 36 inches on one side and we have a label L here, and it says the perimeter of this wrapping paper is 200 inches. So I know that the perimeter.
What's that?
So I need to think to myself, what is perimeter? I know that the perimeter is the distance around the shape. Area is the square units inside, perimeter is outside. So I know that the distance around the shape is equal to 200 inches. Very important. What is the length, L, of this sheet of paper? So what I need to find out is what the length of the wrapping paper is. So what it's important to do is find out what we do know. Very often when we are finding area or perimeter, and we are looking at a test, what they'll do is give you the information on some of the sides, but not all of the sides. That may give you one side of a square or 2 sides of a rectangle. So what I highly suggest you do is go ahead and label as many sides as you can so that you don't forget to include those in your calculations, okay? So if I know, what I know about a rectangle is that opposite sides have the same length. So I know that this side is 36 inches, so I'm going to go ahead and I'm going to label the other side as 36 inches as well, okay? So I already know that piece of information. What I'm going to find out then is the length of both of these 2 sides, okay? So I do know that these 2 sides equal 36 inches. What I also know is the distance around the total shape is 200 inches. So how am I going to find out the length? Well, let's figure out what we do know. If we're going to add all 4 sides, it's going to equal 200. So let's add the 2 sides first. 36 plus 36, or we could multiply it 36 times 2, right? Well, we have a calculator, so let's go ahead. If you're not sure what it is, if you know that fact, that's great. If not, let's go ahead and use our calculator because we're allowed to do that. I'm sorry, 36. I just typed in 32. 36 times 2 equals 72. Okay, so I'm going to go ahead and I'm going to work things out here. Okay, 36 times 2 equals 72. Okay, there we go. So I know that these 2 sides add together to make 72. I know that if I add the whole thing together, it equals 200. So what I want to do is find the difference between 200 and 72. And I know that difference is going to come together to make up those 2 sides. So what I then want to do is take 200 and I want to subtract 72. And that difference is going to make the total of these 2 sides. So again, we have our calculator. Let's go ahead and use it. 200 minus 72 equals 128. Now let's be very careful here, because if you look at the answer choices, you will see both 72 and 128. So if I stopped at any part in the middle, look, those answers are right there to catch us, to trick us. So you need to be very careful, because remember that 128 is the total for these 2 sides. Okay, because remember that perimeter is the distance around the whole thing, and 128 is the total of these 2 sides. So I have one final step, And what I want to do now is 128 divided by 2. And let's go ahead and use that calculator. We have it. 128 divided by 2 equals 64. And let's see if that answer choice is here. It is. Now, let's go ahead and label it, and we're going to make sure to as well use our labels. Now, if we had time, and hopefully you do have time, you can go ahead and continue working on your test. But if you have time at the end of the test, one excellent thing is to go back and check your answers. So if you had time, what I would highly suggest you do is to come back to this problem and go ahead and add up all those signs. So go ahead and add up 64, 36, 64, 36. You could do 2 times 36 and add it up with 2 times 64. Add it together and you should get your 200, okay? So if you have extra time on MSA, come back, work these things out, but be very careful, because if I stopped at any point in there, those 2 answers were there, so be very careful. But go back, check your work, and not only check that you work things out, check it out. Check out those problems, rework them, see if you got the same answer, because that was a tricky problem, but definitely doable if you take your time.
Excellent suggestion,
Thank
Coach.
you. Okay. And what other problem do we have left? Do we have an ECR?
One problem left, and this is an ECR.
Love ECRs.
ECRs are extended constructed responses, and that usually means that there is an additional part that requires your explanation. So let's go ahead and take a quick look at this.
Do you know why I love ECRs and BCRs?
Why do you love ECRs and BCRs,
I love them
Coach?
because they give you a chance to show what you know. The whole test does, but these give you an additional chance to show everything that you've been taught, to show the world out there how smart Prince George's County public school students are. Absolutely. Thank you.
All right, so let's take a chance to look at this particular problem. And again, remember that my favorite and most important strategy is to read the question very, very carefully and make sure that you understand the question completely. And we see that this is a 5th grade question, and you are allowed to use the calculator.
Here's the calculator.
The calculator will help you. And so let's read the question carefully and notice that we have a step A and we have a second part, that's our step B. So if we look at this particular problem, it says, look at this number line. Here it is, 1 to 5. Step A, plot a point on the number line that represents the location of 2 and 1, 6. So let me go ahead and make sure I'm doing what it asked me to do. It said plot a point on the number line that represents the location of 2 and 1, 6. So if I'm looking here for 2 and 1, 6, it has to be somewhere between 2 and 3. So let me look to see how this number line is actually divided, what segments or intervals are already here. So if I count 1, 2, 3, but it asked me to show 2 and 1, 6. But if I have this already, this is 1/3, this is 2/3, and this would be my 3/3, where my next portion is. So I need to change this so that it is divided up into 6. So I need 6 equal parts. So if I divide each of my thirds into 2 equal parts, then I will have 6. So this would be 1, 6. This would be where my 1/3 is, would be 2, 6. Where my next segment would be my 3, 6, which is the same as 1/2. Then I have my 2/3, which is equivalent to 4, 6. And then I have my next segment, which is my 5, 6. And right here where my whole number is, that would be 6, 6. So I'm going to use the exact same procedure between 2 and 3 so that I can show where 2 and 1, 6 is. So again, I'm going to divide my thirds that are already given to me up into 6. So the parts that I had originally were 1/3, 2/3, and I've added my additional segments to show where 6 are. So this would be 1, 6. This is my 2, 6. This is my 3, 6. This is my 4, 6. This is my 5, 6. So we see that we want to show 2 and 1, 6. So here is my 2 and 1, 6, and it says plot a point. So if it says plot a point, that means to put a point, which is a circle, a colored in circle, there to show where 2 and 1/6 is. Now, this is step A. Remember at the beginning I said this was an ECR. That means they're going to have a step B for us as well. And so in our step B portion, it says, explain why the point you plotted is correct. Use what you know about number lines in your explanation. Use words, numbers, and symbols in your explanation. And since this is an ECR, I'm going to go ahead and read carefully again to see that there's a second portion that I have to answer. It says, Benjamin says that if he divides the number line between 2 and 3 into 2 equal parts, the location of 2 and 1/6 will change. Explain why Benjamin is correct or incorrect. Use what you know about number lines in your explanation. Use words, numbers, and or symbols in your explanation. So again, we need to make sure that we are showing what we know for this particular problem. And for a ECR, you will get credit for everything that is given inside of the box. And so the box actually extends down.
It actually goes further. Woo!
It goes down so that you have a blank space here at the bottom.
And a BCR often has that as well. And this top part here would be what you would normally find in a BCR, which is a brief constructor response. It's just that with an ECR, you've got this extra piece to it. So you might have a little bit of extra space. But a BCR as well, as long as you're answering within that box, you've got all that extra space for drawings, extra things you want to write or add or label. So make sure to use that space up to show everything that you know. Very important.
Okay, so I'm going to slip this in so that I can have some extra space down here at the bottom to show my work.
Excellent.
All right, so it says, explain why the point you located is correct. Okay, use what you know about, and we always want to look for this word about, and then whatever comes after the word about is what we're going to focus in on. Use what you know about number lines in your explanation. And notice that this says explain why. So that means we have to give some reasons. So whenever we're thinking about explain why, we have to give some reasons. Okay, so why is my answer correct? Okay, so we're going to talk about a number line. A number line shows the location of any number. And just because we had thirds here at the beginning, remember that we changed the intervals and changed it into 6. So we can show any number on a number line. Okay, so we want to know, why is my 2 and 1/6 correct? 2 and 1/6 is between 2 and 3. Okay, and notice here, if we're looking at how we place our 2 and 1/6, it was closer to the 2 than it was to the 3. Since it is only 1/6, it is closer to 2 than 3. Okay, and the next thing we did when we were actually showing where 2 and 1/6 was located, we divided the thirds into 2 equal parts. The thirds were divided into 2 equal parts each.
So what you actually...
To show 6.
Yeah, so you were actually showing an equivalent fraction there.
I absolutely was.
1/3 equals 2/6. How cool is that? Love that. So you could even show that either there, or even remember you've got that whole space at the bottom. So you could use all that space you want to.
Okay, so my location is correct. So 2 and 1/6 is 1 space beyond the 2. Okay, so let's look to see, is my 2 and 1/6 one space beyond the 2? Yes, it is, because we have now changed this to 6 instead of thirds. Now, the thing that you really have to be careful about with your ECRs is there is a second portion. So I've answered step 1, part 1 of my step B. So this is part 1. But I have a step 2 that I have not responded to yet. So I am not finished. It would feel like I'm finished, but I have to go back and address the second portion. So my step 2. And that's why it's a great thing that we have an extra part here. So here is my step 2. So let me reread. Remember, reading and understanding is the most critical thing that you can do when you're solving this problem. Benjamin says that if he divided the number line between 2 and 3 into 2 equal parts, the location of 2 and 1/6 would change. Explain why. Again, the explain why is there. Benjamin is correct or incorrect. Well, let me always refer to my number line here. So Benjamin said if I change this so that I have the location of between 2 and 3 into 2 equal parts. And notice here that when we were originally drawing this, we put 3/6, which would mean this is equal to 1/2, which means I have 2 equal parts here. So here I have 3/6, which is the same or equivalent to 1/2. And so if I label this as 1/2, my location for 2 and 1/6 did not change. So Benjamin, you are incorrect. So the first thing we have to do for our ECR is to address, is he correct or incorrect? He is incorrect. So we need to say that Benjamin is incorrect. He is wrong. So you can say incorrect or wrong, Benjamin. Okay, so now we need to go back and explain why he is incorrect. Okay, so the equivalent fraction.
Yeah, this is probably more where the equivalent fractions would come into play.
The equivalent fraction for 2 equal parts is 1/2, which equals 3/6. So notice here I'm using numbers and symbols, and I'm not writing as many words. Okay, so the equivalent fraction for 2 equal parts is 1/2, which was equal to our 3/6. The location, or I can say position, whichever word I like, the location for 2 and 1/6 did not change. Okay, so just because you divide your fractions, the number of parts, a number line is divided into does not change the value of it.
And while Coach Davis is writing this, she's doing such an excellent job on answering this ECR. What's important to notice is once you read the BCR, what myself as a teacher, what I like to do when I'm reading a BCR or an ECR at the end is say, do I have any questions left in my mind that they understand? And after you read this ECR, you can tell that she has such an excellent understanding of number lines and where to show mixed numbers on number lines. And that's what you can ask yourself at the end of a BCR, ECR. Would whoever's reading this have any questions left that they understand? And once you read this, you can see that she shows, Coach Davis clearly shows complete understanding. And I think it's just an absolutely excellent ECR. Sorry, you may not be finished, but I just wanted to share that. That's how I look at BCRs and ECRs. Are there any questions left in our mind that they understand?
Okay, so the equivalent fraction is for 2 equal parts is 1/2, which was equal to our 3/6. The location for 2 and 2/6 did not change. The number of parts on a number is divided into a number line. Okay, so let's go back and reread. A number line is divided into does not change the value of or position of a point.
And Coach Davis is also doing another excellent strategy, which is to go back and check and reread your BCR once you're finished and see if there's anything that you want to add or change. And one thing, if I might, just add one small thing. Anytime you're showing equivalent fractions, whether you're showing your work or explaining in a BCRs, I always like to show how we got that equivalent BCR. And what we did here is we multiplied both our numerator and denominator by 3. And that way, if we just put times, it's probably too small for you to see. But I showed that my numerator and my denominator are multiplied by 3, so we can just show how we found that equivalent fraction. So.
And we can also check.
Yes.
Remember how we can use words, numbers, pictures, and symbol. And so if you notice here, I have 3/6 above on my number line. I have thirds right here, and I have written 1/2 here on my number line. So that's an example of using those pictures to help you out. So please make sure you take your time and you do neat work when you're writing your ECRs or BCRs. And so it has been our pleasure to help you get ready for the MSA, because we know all students in Prince George's County are better than basic. They are proficient and advanced. I am Coach Davis here with my fabulous partner.
Thank you, Coach Sun, and we wish you good luck, and we know that you will make us proud. Have a great day.